Welcome to A-Level and AP Physics. In today's class, we will discuss March 2021 paper 1-2. There are 40 questions in this paper and the total time for this paper is 1 hour and 15 minutes. The total mark for this paper is 40. You will get 1 mark for each correct answer. If you need to do any rough working, you need to do on this question paper. There are 40 questions on this paper. Answer all the questions. You need to answer all questions, and there are 4 possible answers. You need to choose the best possible answer. You need to use soft pencil and you need to record your answers on answer sheet. Don't use any correction fluid. Don't write on any barcodes. You may use a calculator, means you can use calculator for this exam. Useful data is also given here. It simply means that some constants and the values are given. If you didn't remember any constant and you need for any questions to answer, you can come and you can find here. For AS level especially, you need to understand the value of G. The value of G you have to use in your exam, that is equal to 9.81 meters per second per second. You can also see some useful formulae also given here. This is formulae list. These are very common formulae. For example, you can look at the first one. This is what we need for AS level. I will just draw this rectangle around the formulae you need for AS level. This is also what you need for AS level. We don't need this one. This formula you also need for AS level here. Resistors in parallel, resistors in series you need for AS level. So these are the formulae you need for AS level. If you didn't remember them, you can come back and you can find them here. For AS level, you also need Doppler effect formula. Means Doppler effect equation you also need. If you look at this one at the bottom, you can see there is a plus and minus sign. So what's meaning of that? When to use plus and when to use minus? We need to understand if the source is approaching observed frequency, this one has to be greater than the source frequency, and this is true when the source is approaching. Source is approaching. So if the source is approaching, then you have to use the negative sign. Means the formula you have to write down, this will be Fs V over V minus Vs. So you have to use the negative sign here. When the source is moving away, then F observed has to be smaller than Fs, moving away. So we can write down when the source is moving away, then the formula you have to use F observed has to be equal to V over V plus Vs multiplied by the frequency of the source. Fs, S here is for source. So Fs is frequency of source, O for observed frequency, observed. So this is very important one you need to understand. First question is about reasonable estimate for the density of sand, and this type of questions are very common in this paper. Most of the time question 1 is about reasonable estimate. We need to understand how to approach this type of problem. The best way to approach this type of problems is comparison. Means you need to compare with something known. Comparison with something you already know. So we can write down comparison with something known. That is the key concept you need to understand to answer this type of problems. For this question, we need to estimate density of sand. So the best way to estimate density of sand is density of water. And density of water is about 1 gram per cubic centimeter. Now, next thing you need to understand, if we have, let's say, this is a glass of water, and if we place sand inside this glass of water, sand will sink and finally sand will stay at the bottom of the glass. From here we can conclude density of sand is greater than density of water. This is greater than density of water. Next thing we need to understand the density of mercury. Density of mercury is about 13.6 grams per cubic centimeter. meter. Now we need to understand the density of sand is much less than density of mercury. So we can simply estimate the density of sand can be around 2 to 3 times of the density of water, or simply we can say about 2 or 3 times. Even if you don't know it is 2 times, 3 times, 4 times, if you go through the options, you can find out the answer very easy. First of all, if we look at the first option, this is telling us density of sand is 200 times of density of water, so that is not possible option because the density of mercury is only 13.6 times. If we go to the second option, this is 2000, so this is telling us density of sand is 2000 times of density of water, that is also not possible. If we go to next one, this is 20 kg per cubic meter, so this is telling us the density of sand is 50 times less than density of water, so this is 50 times, or we can simply write down in a little different way. We can also write down like this. This is telling us this is 1 over 50 of the density of water. That is also not density of sand because sand is denser than water, so this is not possible option. If we look at last option, this is telling us density of sand is about 2 times of density of water, so this is a reasonable estimate, so this is our answer. Question second is based on physical quantities and the units. For this question we need to find out which physical quantity can have this unit. If we look at the first physical quantity, acceleration we can simply denote with letter A, and this is equal to force over mass. The unit of force is Newton and the unit of mass is kg, so it means this is not answer, so this is Newton per kg, so this is not possible answer. If we go to force, the unit of force is Newton and this is equal to kg meter per second square, kg meter per second square, so this is also not possible option. If we go to mass, for example mass, we can write down mass is equal to force over acceleration, so simply we can write down unit for force is Newton and the unit for acceleration is meter per second square, so this is meter per second square, so simply we can write down this is Newton second square per meter. This is correct answer. But if we look at momentum P, this is equal to mv, unit of mass is kg and the unit of velocity is meter per second, so this is also not possible answer, so the answer is C. For this question a velocity vector is given. As you can see here, the magnitude of the velocity is 75 and the angle with vertical, this is equal to 30 degrees. Question is asking us about the components of the velocity vector in north direction and also in east direction, so simply we can write down is asking us about vertical component and horizontal component. Vertical component simply is equal to v cosine of angle, means this angle, cosine of this angle. V in this case, this is equal to 75 and cosine of 30 degrees. Simply if we solve this one, this is equal to 64.9 meters per second. So this is our vertical component in this direction. We need to find out the horizontal component, that is equal to v sine of angle, sine of this angle, so simply we can write down this is 75 times sine of 30 degrees. In this case our final answer will be 37.5 meters per second, or approximately we can say this is equal to 38 meters per second, so this is correct answer. For this question, a micrometer screw gauge is used to measure the diameter of a copper wire. We have two diagrams here, diagram 1, diagram 2. Diagram 1 is when the wire is inside the jaws of the micrometer. So this is shown in diagram 1, means with wire. When the wire is inside the jaws of micrometer, we can simply write down this is with wire. This is without wire, when the wire is removed and jaws of micrometer are closed. This is without wire, so simply we can write down this is diagram without wire, when wire is not inside the jaws of micrometer, without wire. And if you look at this one, the reading on this is equal to 14, means the circular scale reading is equal to 14. So this is 14. If you multiply this one with the least count of micrometer, that is equal to 0.01 mm. So this is equal to 0.14 mm, and this is zero error, but this is positive. This is zero error, but this is positive zero error because this reading is greater than actual. So we can say this is positive zero error. So as you can see here, this is positive zero error. This is 0.14 millimeter. I have already written here. We need to understand how to read this. In this case, you can see the linear scale reading, that is equal to 2.5, and circular scale reading, that is 9. If you multiply 9 with 0.01, again you will get this is 0.09. Now we need to add these two, so this is our final answer. Mean this is the reading on this one. This is reading on micrometer, so we can write down reading on micrometer. This is reading on micrometer, but this is not the final answer, and this is not the diameter of the wire. In order to find diameter of the wire, we need to subtract this one because this is positive zero error. So this is the reading higher than actual, so we have to subtract. And our final answer is this. So B is the final answer. If instrument has positive zero error, it simply means that the measured value is always greater than actual value. Or simply we can say the measured value minus actual value, that is equal to positive zero error. So simply we can say that will be equal to zero error. All the readings will be greater than by this amount. Zero error is an example of systematic error because all the readings will be greater than actual value if this is a positive zero error, and if it is negative zero error, all the values will be smaller than actual value. For this question, current is given, the mean value of the current with absolute uncertainty is given. Potential difference, its mean value and absolute uncertainty is given. We need to calculate the percentage uncertainty in the calculated resistance. Now, first of all, we need to understand how potential difference, current and resistance, they are linked together. They are simply linked together by Ohm's law. This is very simple, Ohm's law. V is equal to IR, so R is equal to V by I. Now you can see these two quantities are divided. So it simply means that we need to add the percentage uncertainties to calculate the percentage uncertainty in resistance. For that reason, we have divided absolute uncertainty by the mean value of potential difference plus absolute uncertainty in I divided by its mean value. Multiply by 100, then just simply solve this one, and this is the percentage uncertainty in resistance. For question 6, it is given there are 4 cars A, B, C and D. They move from rest in a straight line. Cars take the same time to accelerate to a velocity of 60 kilometers per hour. The VT graph is shown in this figure. We need to find out which car reaches a velocity of 60 kilometers per hour in the shortest time. That is the main thing. First thing, now we need to understand what is area under VT graph. Area under VT graph, so let me write down here. Area under VT graph, this is equal to displacement. So simply we can write down this is equal to displacement. As cars, they are moving in a straight line, so displacement and distance, they are equal. So we can also write down this is equal to distance. The next thing we need to understand, the shortest distance. Shortest distance simply means that the smallest area, the smallest area. Now simply we need to find out the curve with the smallest area, means the VT graph for a curve which has the smallest area. So this curve, if you look at the D, this area is the smallest, so the answer is D. This question is about projectile motion. It is given to us that a cannon fires a cannonball with an initial speed v at an angle alpha to the horizontal. We need to find out the maximum height reached by the cannonball. This question is asking us about maximum height. So we need to consider vertical motion only. So we will consider vertical motion only. For this purpose, we will take upward as positive. Now, if we look at the initial speed, we can resolve into two components. So this is a horizontal component and this is vertical component. Vertical component is simply equal to V sine of alpha. And the second thing we need to understand, at the peak, V vertical means V final in vertical direction, that will be equal to 0. Now if we have these two, then we can write down the U means the initial speed, this is equal to V sine of alpha, and the V final means the final velocity at the peak, that is equal to 0. Now we also need to understand acceleration is equal to G, and direction of acceleration is always down, so it means it is negative because we have taken up this positive, so this one is negative. Next thing we need to find out the vertical displacement. Let's say this is S and this is equal to capital H, the maximum height. Now simply we need to use SWOT equation, so we can write down S is equal to V square minus U square divided by 2a. V is equal to 0, so simply we can write down this is 0 minus we have V sine of alpha square divided by 2g, but g is negative, so this is negative g. Now simply if we solve this one, we will get this is minus V square sine square alpha divided by minus 2g. So negative cancel, and our final answer is this one, and this is the maximum height reached by cannonball. So the answer is C. For question number 8, it is given that a ball strikes a horizontal surface with momentum p at an angle theta to the surface as it is shown in this figure. The ball rebounds with the same magnitude of the momentum at an angle theta to the surface. The ball is in contact with the surface for time t. We need to find out what is the magnitude of the average resultant force on the ball during the collision. So first of all, we need to understand how to calculate average resultant force. Average resultant force is equal to the change in momentum over time. But time is already given, that is equal to t, so we no need to worry about time, we no need to calculate. This is equal to t. We need to find out what is the change in momentum. So we need to find out P final minus P initial. Now let's say this is our P initial and this is P final. First of all, we will answer this question by resolving vectors into its component. Let's resolve initial momentum into its component. So if we resolve initial momentum into its component, you can resolve like this. So this vertical component is simply equal to P sine of theta, because this is opposite to the angle, so this is P sine theta. And with angle, this is P cosine theta. The same we need to repeat for this final momentum. So we can also resolve this one into its components. So this is horizontal component and this is vertical component. Horizontal component, again this is equal to P cosine theta, and vertical component, this is equal to P sine theta. We will check change in momentum in x direction, also change in momentum in y direction. First of all, let's try to find out change in momentum in x direction. We will take to the right as positive. So the delta P along x direction, this is simply equal to P cosine of theta, means the P final in x direction minus P initial in x direction. P final, this is P cosine of theta. P initial is also P cosine of theta. So final answer is 0. So there is no change in momentum along x direction. Let's try to find out change in momentum along y, means in y direction change in momentum. So simply we can write down delta P in y direction, this is equal to P in y direction final minus P in y direction initial. For that purpose we need to take one direction positive because one momentum is down. This component down, that is up, but we will take up is positive. So this component is positive and this one will be negative. Simply we need to plug in values. So P final, simply we can write down this is P sine of theta and P initial, this is minus P sine of theta. Now minus minus if we multiply plus, so this is P sine theta plus P sine theta. Simply this is equal to 2 P sine theta. So this is the change in momentum. So we can simply write down this is 2P sine of theta divided by T. So our final answer is D. Now we will answer this question using the different methods. In the last method we have discussed how to answer this type of problem by resolving vector into component. In this method we will study how to answer this type of problem by adding vectors. Here we have two vectors. Let's say this vector is P1 and this vector is P2. We need to find the change in momentum because we need to find out the force, the average resultant force. This is equal to delta P over T. T is the same because in question it is given time is equal to T, but we need to find out delta P. Delta P simply we can write down this is equal to P2 minus P1. We can also write down this one P2 plus minus P1. Now from here it simply means that we need to add two vectors P2 and minus P1 and that will be equal to delta P. Now simply we need to add these two vectors P2 and minus P1. Minus P1 simply means that this vector has the same magnitude as P1 but its direction is opposite. What exactly it means? It means that P1 and minus P1 they have the same magnitude. Their direction is opposite because P minus P1 is a negative vector of P1. So this is our minus P1. Simply we need to add these two vectors means P2 and minus P1. First of all let me draw P2. So we will draw one line equal to this vector magnitude P2. So this is our vector P2. We will take this vector from here and place here. So this is our P2. Now we will repeat the same process for minus P1. So this is our vector minus P1. We can also adjust. So this is minus P1 we will place here. So this is how you can add these two vectors together. So this is minus P1. Now we need to find out the resultant vector. Simply you need to add these two vectors together. So this is the resultant vector. This is our vector P2. So let me label first of all. This is P2 and this is minus P1. The magnitude of this one, this is equal to P, and the magnitude of this one, this is also equal to P. And this vector, let me draw arrows here. So this is P2 and this one is P1. And this is our vector delta P, means the difference between these two. So this is delta P. Now if you look at P1, P1 is making angle theta with horizontal. So this angle is theta. We can simply write down this is theta and this angle is also theta. Now we can divide this one into two parts, this triangle. So this side means this half of that from here to here. So this will be equal to delta P by 2. And this half, this will be equal to delta P by 2. If we look at sine of angle, sine of theta, this will be equal to delta P by 2 divided by P means this one. From here we can find out delta P is equal to 2P sine of theta. So simply this is over delta P, this is equal to 2P sine of theta divided by T, and this is over answer. This is kind of typical question about skydiver and terminal velocity. First of all, let's try to understand this question with the help of VT graph. So let me write here velocity on vertical axis and time on x-axis. So at the beginning, when the skydiver will jump, velocity of skydiver will increase like this. Finally, it will reach a terminal velocity. So at this point, we call first terminal velocity. Now, if you look at this one, you can easily understand velocity is increasing but the gradient is decreasing. It simply means that the acceleration of skydiver is decreasing with time, and finally at this point acceleration is equal to 0, or simply we can say at this point mg is equal to a resistance, or we can say is equal to drag force. We can say simply is equal to drag. But for this question, it is given to us opens his parachute. So when skydiver will open his parachute, at this point velocity suddenly will decrease and again it will reach a terminal. Now we need to understand at this point why velocity decrease. Because when this skydiver is falling down and suddenly open this parachute, drag force increase dramatically. This one is the drag, so this will increase, but weight remains same. So now acceleration is upwards, but still skydiver is falling down, velocity is still down. In this case, skydiver will slow down. Its direction is still downwards. So simply direction of velocity is still downwards, but magnitude of velocity decreases. That's the reason answer is A. For this question, it is given a stationary firework explodes into 4 fragments, mean into 4 pieces, which travel in different directions in a horizontal plane. Now, first of all, stationary is very important. From here, we can understand initial momentum is equal to 0. So the final momentum also has to be equal to 0 because this is an isolated system. So simply we can say that in any direction, change of momentum has to be equal to 0. So we can simply write down in any direction, delta P has to be equal to 0. This is the main concept we need to answer this problem. Now, if you look at all these fragments, the angle between these vectors is 90 degrees. You can see this angle is 90 degrees. This is also 90 degrees. So it means that vectors are perpendicular to each other. We no need to resolve into components. Or simply you can treat, if you take this direction is x direction, so simply I can write down. Let's say this direction is x. We can say this is y direction. So you can also write down like this. We need to find out the velocity of this fragment x. For this one, it is given to us. We have the mass of this fragment, we have velocity. So simply we can say that 10g times 300 meters per second. This one has to be equal to 15g times, let's say, velocity v. From here, we can find out that will be equal to 200 meters per second. So our answer is A. Welcome to A-Level and AP Physics. In today's lesson, we will discuss important past paper questions from March 2020 paper 1-2. In this lesson, we will discuss these questions in detail so you can have better understanding about these concepts. We will not only find the best possible option, we will also go through incorrect options. I will explain why those options are not correct. For question number 11, it is given to us a particle with mass moves in a horizontal straight line through a uniform electric field in a vacuum. So in a vacuum, it simply means that we can ignore air resistance. So this is simply telling us we can ignore air resistance, mean air resistance is equal to 0. It is also given to us that there is a significant gravitational effect on the motion of the particle. It means we cannot ignore gravity. We have to consider the effects of gravity in our calculations. Question is asking us what could be the direction of the electric field and the sign of the charge. So first thing we need to find out what is direction of electric field. This is one thing we need to find out. And the second thing we need to find out what is the sign of the charge. First of all, let's imagine that there is only one force acting on this particle. Let's say that force is gravity. If there is only gravity acting on this particle and gravity is always acting vertically downwards, then the motion of this particle, the path this particle will take, that will be parabolic path. Means particle will move like this. But we want this particle to move in a horizontal straight line. So it simply means that forces acting along vertical direction, those forces has to be balanced. One force we have, that is mg, that is acting down. But particle is moving in a uniform electric field. There must be another force acting on this particle. That force has to be electric force, and this one has to be equal to mg. But we understand electric force is equal to eq. So from here we can say that Fe has to be equal to mg if this particle is moving in a horizontal direction. Now let's try to look at these options and try to find out the answer. If you look at option D is telling us there is no charge on particles. If no charge, it means there is no electric force. So particle will follow this parabolic path. So this is not possible option. So this is incorrect option. So simply we can eliminate this option. We can eliminate this one. We left with three options. We look at all these options one by one. First of all, it is given to us electric field direction is down. So simply we can draw our electric field like this. So electric field is pointing down and the charge is negative. If the charge is negative, so the force on the charge here, let's say this is our negative charge. We can also say this side is positive. If you're not very clear, you can also say the positive and negative. So the force on this particle will be up, and this is direction of electric force on this particle. So this is possible option. So we can say this can be correct answer. Let's look at option B now. For option B, it is given to us electric field is still acting down, means direction of electric field is down. This is pointing downwards and this is uniform electric field. But in this case, the sign of the charge is given. The sign of the charge is positive. If this is positive, so it will move in direction of electric field. So it simply means that it will experience electric force in downward direction. So this is not possible answer because electric force has to be pointing upwards. So this is not possible option. For option C, direction of electric field is upwards and the sign of charge is negative. First of all, let's write down this is option C. For option C, direction of electric field is upwards. So this is our uniform electric field. We can draw like this. And the sign of charge here is given, that is negative. So this is our negative charge. We can also say this side, this plate, let's say it is between two plates. So this plate has to be positive and this plate has to be negative. Now negative charge is placed inside this uniform electric field. This will experience force in direction opposite to the electric field lines, means opposite to electric field direction. So it will experience force down. So this is also not possible option because electric force has to be pointing upwards. Our answer is A for this question. For question number 12, it is given to us that there are two forces, two parallel forces, each of magnitude f, act on a rod of length 5d. Which diagram shows the positions of the two forces that will produce the largest torque on the rod? First of all, we need to understand what is torque. This is turning effect of a couple. So this is simply first thing you need to understand. What is the torque? Torque is turning effect of a couple, that is torque. So this is the first thing you need to understand. Torque simply we can write down, this is equal to the magnitude of one force times the perpendicular distance between two forces. Perpendicular distance between two forces. So this is how we define the torque. If you look at option A, in this case these two forces, they form a couple because these two forces, the magnitude is the same. They're acting in different directions and they're not acting along the same line. In this case, if we need to find, the torque will be simply equal to Fd. So this is how you can find the torque of this couple. If you look at option B now, option B, if you look at these two forces, these are like parallel forces. Like parallel forces, these are parallel forces, but these two forces, they do not form a couple. In this case, this rod will not rotate. It will not rotate because these two forces, they do not form a couple, and two like parallel forces do not produce torque. We can simply write down, do not produce torque. So this is the point you need to understand, because these are two like parallel forces, they do not form a couple and also they do not produce torque. So in this case, torque will be equal to 0. So simply you can say that tau, in this case, tau will be equal to 0. So simply we can write here. If you look at option C, for option C, again we have two forces and these are like parallel forces. Again, these are two like parallel forces. We can again write down, these are two like parallel forces. They do not form a couple and they will not produce a torque. Do not produce a torque because they do not form a couple and they're like parallel forces. They do not produce torque, or simply we can say torque in this case will be equal to 0. So for C, tau is equal to 0. Now if you look at option D, these two forces, they form a couple. They have the same magnitude, they're acting in different directions, they are not acting along the same line, and they are separated by this distance. This is the perpendicular distance between these two forces. If we need to find out the torque produced by this couple, and that is equal to magnitude of one force times the distance between two forces, perpendicular distance between two forces, that is equal to 2d in this case. So simply this is equal to 2fd. If you look at all these options now, we can find the best possible option. We simply need to compare A and D. So this torque is the largest. This is our best possible answer. For this question, it is given to us a mass of 30 kg is suspended from the end of a wire. So you can see this is the mass. So this is our mass and it is suspended at the end of a wire. This one is the wire. You can see this is the wire. It is also given to us there is a horizontal force F that is acting here. So this is horizontal force acting along horizontal. It is also given that this is in equilibrium. So equilibrium simply means that the resultant force acting on this mass is equal to 0. Resultant force in any direction. It means if you look at the forces acting along horizontal, they has to be equal to 0. And if you look at forces acting along vertical, they also has to be equal to 0. So it simply means that F net in x direction has to be equal to 0 and F net along vertical also has to be equal to 0. We are not talking about z, so if there is z, it also has to be equal to 0. So simply we can say along x and along y, resultant force has to be 0. Second way to understand equilibrium is that if we draw the vector diagram, so next thing we need to understand, if we draw the vector diagram for any object that is in equilibrium, then the forces must form a closed polygon. Means it can be triangle, it can be rectangle, polygon. They must form a closed polygon. We will use this vector addition method to answer this question. Let's try to draw the vector diagram. Before we draw the vector diagram, we need to find out the forces acting on this object. First force, we can say the acting on this object, this is the mg, this is the gravity. The second force, F, horizontal force is given, and the third force is the tension in the string. So this is acting along the string in this direction. Now we need to add all these forces. First of all, let's draw weight. This is gravity that is acting vertically down. The second, we have horizontal force that is acting along horizontal. The last one, this is the tension. So this is the tension force. So we can complete over this vector diagram. So we can also label, this is the mg and this is the force F, and this force is tension, this is T. We also need to understand this angle as it is given here. This angle is equal to 30 degrees. We can also label here. Now if we look at this angle, we can simply write down that tangent of 30 degrees, that will be equal to the opposite side divided by adjacent side, that is mg. From here simply we can find out F, that will be equal to mg times tangent of 30 degrees. But we have value of mass, we can simply plug in value of mass, and g, this is 9.81. Then we just need to multiply with tangent of 30 degrees. If we do this calculation, our answer will be 170 newtons. So the answer for this question is C. Let me explain to you this question using a different method. In this method, we will resolve forces into their components and we will find the value of horizontal force. For that purpose, we need to resolve tension into its component. If you look at tension, it has two components. It has one component that is acting vertically up. So this is one vertical component, and it has another horizontal component that is acting opposite to this horizontal force. This component means the vertical component. This is equal to T cosine of theta, or simply we can say this is equal to T cosine of 30 degrees, because this is with this angle. If we look at horizontal component, this is equal to T sine of 30 degrees, because this side is opposite to this angle. So this is T sine 30 degrees. Now we need to equate forces along x direction and along y. If you look at x direction, we have two forces. F is acting to the right, so this is acting to the right, and x means the x component, the horizontal component of tension, this is acting to the left. So this is simply T sine of 30 degrees. These two has to be equal because this mass is in equilibrium. This is acting to the left. These two forces are equal. Now if you look at forces acting along y direction, we can simply write down, we have this force means the gravity that is acting vertically down, but we have a component of tension that is acting vertically up. So from here simply we can say mg, this is acting vertically down, this has to be equal to the component of tension that is acting vertically up. Now simply we can also draw like this here. This is F, and we have component of tension that is acting this way, and this is T sine of 30 degrees. For this one we have mg that is acting down and component of tension that is acting vertically up, and these two forces, they are equal. This is T cosine of 30 degrees. Let's say this is equation 1, let's say this is second. Now simply if we divide 1 by 2, then we can write down F over mg, this is T sine of 30 degrees divided by T cosine of 30 degrees. Tt we can cancel, then we simply left with F over mg, or simply we can say this is mg tangent of 30 degrees. Same equation we have. We need to simply plug in values. G is 9.81. This is tangent of 30 degrees. If we solve this, we will get value of F that is equal to 170 newtons. And this is our final answer. That's correct option. C is correct option. Welcome to A-Level and AP Physics. In today's lesson, we will discuss important past paper questions from March 2021 paper 1-2. These questions are very important for your exam because you will see the same kind of questions in many past papers. We will discuss these questions in detail so you can have better understanding of these concepts. For question number 14, it is given to us a balance is used to measure the mass m of a number of cylindrical metal rods of length L. All the metal rods, they have the same radius R. The graph is given here. You can see on y-axis m is given, on x-axis L is given. The gradient of the graph in this case is equal to capital G, and for this question we need to find out which expression gives the density of the metal. First of all, let's try to visualize, means try to see the picture of this question. For that purpose, we need to sketch this cylindrical metal rod. So this is our cylindrical metal rod as it is given in this question. The radius of this rod is given, that is equal to small r. So this is the radius of the rod. Now let's say the length of this rod is equal to L1. Let me sketch another rod so then we can compare these two rods. Let's say this is our second rod, and this second rod also have the same radius. This rod also has the same radius and its radius is equal to small r. Let's say the length of this second rod, this is equal to L2. This is. Now if I ask you, these two rods, they are made of the same material, they have the same shape, only difference is that one is longer and the other one is shorter. Let's say the mass of this shorter rod, this is M1, and the mass of the longer rod, this is M2. You will simply say that in this case M2 has to be greater than M1 because L2 is greater than L1. This is what is given in the graph. You can see as the L is increasing, it is increasing this way, and the mass is also increasing. Means mass and L, they are directly proportional because the rods, they have the same shape, they have the same radius. So it means same material, they are made of the same material. So let me write down here. As they are made of the same material, so it simply means that they have the same density, same material. It means the density is the same, radius is the same, the radius is same. So what does it mean if the radius is same radius also means that the cross-sectional area of each rod, this is also the same. Now we have to use these concepts to answer this problem. Let's try to find out how we can find the mass of each rod. If we need to find the mass of rod, simply we can say that that has to be equal to the density of the rod, means the density of the material, times the volume of the rod. So V is the volume. In this case, the shape of each rod is cylinder, so the volume of cylinder simply is equal to A times L. A is the cross-sectional area. We can also write down the cross-sectional area. This is pi r squared times L. In this equation, density is constant, radius is constant, so we can place them on one side. So this is rho pi r square. We can draw two brackets across them, and this is L. If you look at this equation now, this is straight line equation. We need to compare this one with y is equal to mx plus c. C is the y-intercept, but in this case the line is passing through origin. It simply means c is equal to 0. X quantity is L because this is plotted on x-axis, and the gradient here we can write down m is the gradient, and m is equal to rho pi r square. So this is the gradient. For this question, it is given to us the gradient of the graph is equal to capital G. It simply means that we have to replace m with capital G. So this is a gradient, and the value of gradient here, that is equal to capital G. So this is pi r square. We need to find out density, expression for the density of the metal. So rho is the density. Simply we need to rearrange, then we can write down rho is equal to capital G divided by pi r square, and this is expression for density. That's the answer. So this is our final answer. For question number 15, it is given to us there are two blocks X and Y. This is block X and this is block Y. They are on a horizontal frictionless surface, so this surface is frictionless. The mass of block Y is greater than the mass of block X. Block Y has a spring attached to its end. You can see this is the spring is attached at the end of block Y. The blocks are pushed together, the spring is compressed between them, and the blocks are stationary. When released, blocks move in opposite directions. We need to find out which statement is correct. For option A, it is given to us after release the kinetic energy of block X must equal the kinetic energy of block Y. Simply we can write down according to this statement, kinetic energy of block X is equal to kinetic energy of block Y. If we look at our system, we can simply understand it is given to us the blocks are pushed together, means we apply force F, let's say on this block, and we apply some force F on this block, and we push them together, and the spring between these two blocks is compressed. Now if we remove these forces, we remove these two forces, block Y will go to the right. Let's say the velocity of this block is Vy, and the block X, this will go to the left. Let's say the velocity of block X is Vx. This is an example of explosion, means system will split into pieces, into smaller parts. So this is an example of explosion. For an isolated system, if system is isolated, means there is no net external force acting on the system, then momentum before explosion has to be equal to momentum after. So we can write down momentum before has to be equal to momentum after. It simply means that momentum before is equal to 0. It simply means that the momentum of X must be equal to momentum of Y. So this is momentum of Y. So Px minus Py, it has to be equal to 0. So this is the first thing we need to understand. If we take this side, for example, this momentum is positive and this has certain momentum, let's say Px, and the momentum of this one will be negative because this is in the opposite direction. So it simply means Px minus Py, this will be equal to 0, or simply we can say the Px, this has to be equal to Py. If we look at kinetic energy, so kinetic energy is equal to P squared divided by 2m. If momentum is the same but the mass is smaller, kinetic energy will be greater. In this question, it is given to us the mass of block Y is greater and the mass of block X is smaller. So we can write down here as mx is smaller than my. It simply means kinetic energy of X will be greater than kinetic energy of Y. So the kinetic energies are not equal, so this is not correct option. As you can see, I have written here momentum is conserved, kinetic energy is not. They have different kinetic energies. Their kinetic energies are different. It simply means kinetic energy of X is not equal to kinetic energy of Y. Let's move on to option B. For option B, it is given after release the sum of kinetic energies of the block is 0. So that is not true because after release blocks are moving with certain velocities As we said, the velocity of block X is Vx, velocity of block Y, this is Vy. The kinetic energy is not zero because kinetic energy is a scalar. So this is also not true option. If we go to option C now, it's telling us the total energy of the spring and blocks before release is zero. Before release is not zero because the work done by the forces we are applying to push them together, that is stored in the system in the form of elastic potential energy. So the total energy before release is not equal to zero. So this statement is also not true. Spring and block system has elastic potential energy. So this statement is also not true. If you look at statement D, means option D, total energy of the spring and blocks is equal to the energy needed to bring the blocks together. It simply means the work done by you or work done by the applied force, that is equal to elastic potential energy, means the energy stored in this system. And this is based on law of conservation of energy. Energy is conserved. So this option is true. For question number 16, we need to find out the work done by gas in moving the piston. How we can find out the work done by gas? Let's say this is W, this is the work done by gas, or this is the work done on gas. That is equal to P external. So this is P external times delta V, and this formula we only use if the P is constant. P has to be constant. So this is very important point you need to understand. When you can use this one only if the P is constant, means P external is constant. Now if you read this question, it is given to us the cylinder has cross-sectional area and the diameter of that one is given, that is equal to 20 centimeters. Pressure of the gas is 102 when the piston is initially 30 centimeters from the base of the cylinder. From the base of the cylinder, so this distance is given, this is 30 centimeters. The gas is heated, causing the piston to move up to, that is 35 centimeters. The pressure of the gas remains constant. Pressure of the gas remains constant, we can also understand like this. At this point, gas is exerting certain pressure, let's say this is P gas, and there is external pressure on the gas, that is P external. These two are equal. That when we heat up, the pressure will increase, the gas will expand, and finally at this point again the pressure of the gas and the external pressure, these two are equal again. So at this point P gas again equal to P external. Value of P external, then simply we can find out from here, this is given, this is 102 because P external is the same. So we can write down this is 102. Now we need to find out the change in volume of the gas. Let's say the change in this height, let's say this is equal to delta H. We need to find out the change in volume, so that simply is equal to the cross-sectional area, we can say pi by 4 d squared times height. So this is the change in height, means delta H. Now just we need to plug in values and we can find out the work done by gas in moving the piston. So this is pi by 4 and d squared, this is in centimeters, so we have to multiply with 10 to negative 2, and the change in height is also in centimeters, 35 minus 30, so this is 5 multiplied with 10 to negative 2. Now if we solve this one, our final answer will be 0.16 joules. So this is the work done by gas in moving the piston. So this is work done by gas. In this case, work done by gas is positive. So this is work done by gas. Option A is correct, and this is the best possible answer for this question. Let me explain to you one more point. P of gas, it is only constant at initial position and at final, but it is not constant between initial and final. Welcome to A-Level and AP Physics. In today's lesson, we will discuss important and tricky past paper questions from March 2021, paper 1-2. In this lesson, we will not only find the best possible option, we will also discuss why the other options are incorrect. This will help you to have a clear understanding of these concepts. For question number 17, it is given to us an egg of mass 25 grams falls vertically downwards from the surface of a table which is 900 millimeters above the ground. Air resistance in this case is negligible, and question is asking us we need to find out what is the kinetic energy of the egg when it hits the ground. This is pretty straightforward question, but the best way to answer this type of questions or any question in physics is to sketch. First of all, let's try to sketch so you can see a clear picture of this problem. For this question, it is given to us that there is a table and the egg is at the edge of the table. We can simply say this is the egg. Height of the table from the ground, this height is given. This is equal to 900 millimeters. Mass of the egg is given. The mass of the egg is 25 grams, or we can divide this one by 1000 and we can say this is equal to 0.025 kg. So this is kgs. This is 900 millimeters. We can convert into meters. We can also divide by 1000. So this is 0.9 meter. Now let's try to understand at this point. We have to understand what kind of energy it has at this point. It has GPE, gravitational potential energy, at this point, and let's say our reference, we have to set a reference line. Let's say at this point means at the ground the gravitational potential energy, this is equal to 0. So this is GPE at the ground, this is equal to 0. We can say this is GPE initial, we can write down, and we can say this is the final one. We also need to understand the kinetic energy here, the kinetic energy. So at this point the kinetic energy is equal to 0 because the egg is not moving. Question is simply asking us what is kinetic energy at this point when this egg will hit the ground. So this kinetic energy we need to find out. Now we can also say that this is initial kinetic energy and this is the final kinetic energy. Simply we need to use law of conservation of energy to find the kinetic energy of the egg. So by law of conservation of energy, we can simply write down by law of conservation of energy, initial kinetic energy and initial GPE means the initial energy has to be equal to the final energy, total energy. We are talking about total energy. In this case, the initial energy, that is equal to initial kinetic energy, means the sum of initial kinetic energy and sum of initial gravitational potential energy. This has to be equal to the final kinetic energy plus the final GPE potential energy. Initial kinetic energy in this case is equal to 0, so we can write down, but initial GPE, this is equal to mgh. Final kinetic energy, this is what we need to find out, so simply we can write down this is kef plus final potential energy, this is equal to 0 because we have taken this reference point and here potential energy is equal to 0. Simply in this case we need to understand kinetic energy final, this is simply equal to mgh. M in this case is 0.025 times 9.81. You have to use 9.81, not 10. Height is 0.9. Now simply we need to multiply. If we multiply this one, we will get this is equal to 0.22 joules. So this is the final answer. So that's the answer for this question. For question number 18, it is given to us an aircraft travels at a constant velocity of 90 meters per second in horizontal flight. Drag force acting on the aircraft is given, that is equal to 2400 newtons, and mass of the aircraft is also given, and this is equal to 2000 kgs. For this question, we need to find out what is the power produced by the thrust force. For this question, it is given to us aircraft is traveling at constant velocity. Constant velocity means that the forces acting on this aircraft are balanced, or simply we can say the net force on this aircraft, this is equal to 0. We can also say that in this case, because thrust is acting to the right, so thrust is acting to the right and drag is acting to the left. So these two forces, there are only two forces acting along horizontal. We can simply say that in this case thrust is equal to drag. These two forces are equal. And drag, the magnitude of drag is given, that is equal to 2400 newtons. It simply means that thrust is also equal to 2400 newtons, but thrust is acting to the right. So this is magnitude of thrust. Now we need to understand how we can find out the power produced by the thrust. Power is rate of doing work, means this is equal to dW by dt. Work, we understand, work is equal to force times the distance moved in direction of force. Simply we can say W is equal to Fs. Now we can replace W with Fs. Simply we can write down here. If the force is constant, means if force is constant, we can take force common, then we left with ds by dt, and this is the velocity. It simply means that power is equal to force times velocity if the force is constant. So very important point, when to use this formula when the force is constant. Now simply we can use this one and we can find out the power produced by thrust force. This is thrust times the velocity of the aircraft, so we can say this is the velocity. Thrust force in this case is equal to 2400 newtons. Velocity is equal to 90 meters per second. So simply we multiply these two quantities, our final answer will be 2.2 times 10 to 5 watts. Answer for this question is B. That's the answer. Question 19 is simply asking us to find the expression which is equal to the stress on a wire. If you look at option A, first of all, option A, this is simply delta x over x, and that is equal to strain. So the first one is not stress because this is equal to strain. Now if we go to second one is force over cross-sectional area of the material, and that is stress. So this expression is for stress. So our answer for this question is B. Let's look at C now. For part C, we need to understand it is given to us force over delta x, and force over delta x, this is equal to K, or simply we can say this is equal to spring constant. Another important quantity, this is spring constant. Let's try to find out what is Young's modulus over original length. First of all, let's try to understand what is Young's modulus. Young's modulus is simply equal to stress over strain. We can write down this is equal to stress over strain. Stress is equal to force over cross-sectional area, and the strain is equal to delta L by L. Now if we rearrange this one, then simply we can write down this is FL over A times delta L. But the expression here is Young's modulus over original length, so we can write down this is Young's modulus divided by L. So this is L naught in fact, so the original length. We can add this is L naught, so this is L naught, and this is equal to F over A times delta L. F is simply, it is the force, but A times delta L, this is the change in volume. So Young's modulus over original length, this is simply equal to force over change in volume. For question number 20, it is given to us a wire is stretched by applying increasing values of force F. For each value of force applied, extension X is recorded and a force extension graph is plotted from the data obtained. Question is asking us which statement about the area under the graph must be correct. First of all, let's try to understand force against extension graph. If you look at this graph, you can simply see we have this one curve, and this curve is the loaded curve. Means when we apply force on the wire, simply we can say this one is the loaded curve. And the second one, let me use a different color. This curve is unloaded, means when we remove force. So this one is unloaded. We can write down the second one. This is unloaded curve. And the area between these two curves, this area is equal to x. So this is area x. And area under unloaded curve, this area is equal to y. Now the sum of these two areas means area x plus area y. This is equal to the total work done in stretching this sample or this wire or this spring. So that is equal to total work. But x means the area between these two curves. This is equal to amount of thermal energy produced, or simply we can say the amount of energy converted into heat energy. And the area under this unloaded curve means area y. This is representing elastic tension energy, and this is the amount of energy stored in the wire, and this is also amount of energy that will be recovered when we remove the force. So this is very important point you need to understand about this curve. There will be a lot of question about this, and you will see question on this curve every year in past paper question, especially in paper 1. You can also understand this one based on if you have graph stress against strain, then the area under unloaded curve, that is also equal to elastic tension energy, and area between these two curves, that is equal to the heat. And elastic tension energy plus heat, if you add these two, that will be equal to the total work done by you in stretching the wire. So that's all what you need to understand about force extension graph and stress strain graph. Now try to answer this question. We need to find out which statement about the area under the graph must be correct. If you look at the first one, it is telling us it can be calculated by 1 over fx. This is not true always. Why it is not true always? Because if the spring or wire does not obey Hooke's law, that will not be true. So let me explain to you with this force extension graph. This is only true if the wire obey Hooke's law, means like this. It obey Hooke's law, then area in this case, that will be equal to the area of triangle 1/2 fx. Only if it obey Hooke's law. But if it does not obey Hooke's law, we cannot calculate area using this formula. If we look at option B, it is given to us, it is the elastic potential energy stored in the stretch sample, EPE, elastic potential energy. It simply means that the total work done by you, it has been stored in the wire in form of elastic potential energy. And when we unload the wire, there is no thermal energy produced. Means the total work done by you has been stored in the wire in the form of elastic tension energy. And when you release the wire, means when you remove the force, all the energy is recovered. And that is only possible if the wire deform elastically. If the wire is deformed plastically, that is not possible. So B is also not best possible option. If we go to C, it is the work done in stretching the sample. It's simply telling us it is the total work done, and this is always true. So the best option is C, and this is true when the wire is deformed elastically or plastically. So this is the best possible option. If we go to option D, it is given to us it is same for any wire of same material. This is not true, because for the same force, if the force is the same, extension is different. If wire has different dimensions, so the area under the graph will be different if dimensions are different. So this is also not possible option. Welcome to A-Level and AP Physics. In today's lesson, we will discuss very important and typical type of questions on waves from March 2021 paper 1-2. These questions are very important to understand waves. For question number 21, it is given to us a progressive radio wave in a vacuum has a frequency of 75 megahertz. We need to find out what is the phase difference between 2 points on the wave that are 50 centimeters apart from each other. We need to find the phase difference between 2 points, and the distance between 2 points is given to us. It is given to us, this is a progressive radio wave, so simply we can say this is electromagnetic waves, and all electromagnetic waves, EM waves, they travel at the same speed in vacuum or in air. So for electromagnetic waves, this is very important point you need to understand. For all electromagnetic waves, their speed in air or the speed in vacuum is the same, and that is equal to speed of light, means 3.0 times 10 to 8 meters per second. Very important point, you need to remember this one because this you need for some calculations. Next thing, we need to understand how we can find out the wavelength, and wavelength simply is equal to speed of wave in medium divided by the frequency of the wave. Speed is 3.0 times 10 to 8 meters per second, and the frequency of radio wave is given, that is 75 megahertz, or we can say this is 75 times 10 to 6 hertz. If we solve this one, we can calculate value of lambda. Lambda in this case will be equal to 4 meters. Now we need to understand how to find the phase difference. In order to find phase difference, we need to understand the ratio between distance over lambda, means the wavelength. This is equal to the phase difference divided by, means it is equal to the ratio between phase difference and 360 degrees, means angle of a circle, total angle in a circle. Now distance is given to us between points, and that distance is 0.50, means this is 50 centimeters. We need to divide by lambda, and then we can find out phase difference. So this relationship is very important. You need to understand this one. Means the ratio is the same. Ratio between distance and wavelength is the same as ratio between phase difference and 360. Now from here we can find out the phase difference, and phase difference simply this side we need to multiply with 360, and our final answer for this one will be equal to 45 degrees. This is how we can calculate phase difference. This is how we can calculate phase difference. Sometimes distance will not be given to you, the time will be given to you, and then you can write down the ratio between time, the given time over time period. T here, this will be the given time, so this ratio is also true. Given time will be given to you, and time period, so this capital T is the time period. So another one, sometimes time will be given to you, sometimes distance will be given to you, but T over capital T, or distance over wavelength, this is equal to phase difference over 360. This is how you can calculate. So our answer for this question is B, and this is the answer. For question number 22, we need to find out which statement is correct for longitudinal waves but not correct for transverse waves. It simply means that which statement is true for longitudinal waves only, but that is not true for transverse wave. In order to answer this question, first of all, let's get one small table. In this column, we have longitudinal waves, and in this column, let's say we have transverse waves. For option A, we can write down here. For option B, we can use this one, and for option D, we will write here. Now we need to find out which statement is true for longitudinal, but that is not true for transverse waves. That if you look at option A, it is given to us, they can form stationary waves. So both waves, means transverse and longitudinal, they can form stationary waves. So this is true for both of them. If we go to option B, it is given to us they can only travel through a medium. That is 100% true for longitudinal waves. that this is not true for transverse waves, because transverse waves, they can travel through vacuum as well, means they can travel without medium, they can travel through vacuum, and they can also travel through medium. So option B is true for longitudinal waves, mean it is correct for longitudinal waves, but it is not correct for transverse waves. So the answer is B. Now if we go to C, they can transfer energy in direction of travels, and they are transverse waves, mean they are progressive waves. Longitudinal wave, transverse wave, they are progressive waves, so they can transfer energy. So this is true for both of them. They consist of peaks and trough. This is true for transverse waves. That this is also true for longitudinal waves. So peaks in terms of longitudinal waves simply means that high pressure. So they also consist of peaks, means high pressure. And trough for longitudinal waves simply means that low pressure. So this option means this statement is also true for longitudinal wave. So our answer is B. For this question, it is given to us: a loudspeaker emitting a sound wave of single frequency is placed a distance capital L from a reflecting surface. So loudspeaker is placed here, and it is at a distance capital L from reflecting surface. A stationary wave is formed with an antinode at the loudspeaker. Means at this point we have antinode is formed at loudspeaker. So this is given to us: antinode is formed here at loudspeaker. This is one important point. The microphone is moved from the loudspeaker to the reflector. So we have microphone that is moved from this loudspeaker to the reflector. Before the microphone reaches the reflector, means before reaching, it detects 4 points where the sound intensity is minimum. 4 points here, intensity is minimum. It means it's simply telling us that there are 4 nodes. So there are 4 nodes. That it is also given to us, it detects where the sound intensity is minimum before the microphone reaches the reflector. So this is very important. So means we have 4 nodes from this point to somewhere here. There are 4 nodes before this microphone reaches the reflector. Now in order to answer this one, we need to sketch the wave first of all. If we can sketch the wave, it will be very easy for us to see. And also we need to understand, on this reflector there will be another node. It means there will be 5 nodes in total. So let's sketch first of all. If we sketch our wave, so this is how you need to sketch. Now you can see here, it was given to us, there is an antinode at loudspeaker. So this one is our antinode. And there are 4 nodes. So you can see these are 4 nodes before microphone reaches the reflector. So we have 4 nodes. So this one is node, this one is node. So here is node, and this is also node. That there is also one node here. So this is the point you need to understand. There is a node at the reflector, and this is the 5th one. Now we need to understand the distance between any 2 consecutive nodes or antinodes. This distance is equal to lambda by 2. Or we can also say that the distance between any 2 consecutive nodes or antinodes, this is equal to lambda by 4. And you can see from here now, so this distance, this also will be equal to lambda by 4. And next distance, this also will be equal to lambda by 4. And distance between next antinode and node, this distance also will be equal to lambda by 4. And between next node and antinode, this distance is also lambda by 4. And you can keep on writing, this is lambda by 4. So here also this distance will be lambda by 4. And next one, this also distance will be lambda by 4. And the last one, this distance also lambda by 4. Now simply we need to count how many lambda by 4. So this is 1, this is 2, 3, 4, 5, 6, 7, 8, and 9. So in this case, L is equal to 9 lambda by 4. So simply we can write down like this. Question is asking us, we need to find out wavelength. Means we need to find out lambda. So in this case, lambda will be equal to 4L divided by 9. And this is what question is asking us to calculate. So the answer for this question is C. That's the answer. So the main concept what you need to take away from this question is that the distance between any two consecutive antinode and node, that distance is equal to lambda by 4. And the second concept you need from this question is the distance between any two consecutive nodes or antinodes is equal to lambda by 2. So these are the two main concepts you need. Means these are the takeaways from this question. For question number 24, it is given to us a source of sound of frequency f at point z is moving at a steady speed. Means steady speed means the speed is constant. The pattern of emitted wavefronts is shown. This is pattern of emitted wavefronts. Question is asking us which row describes the frequencies of the sound heard by stationary observers at x and y. So we have one observer at point x, so we can draw one observer here, and another observer is at point y. We can draw another observer at point y. Now this source we need to understand. There are 2 points we need to understand from Doppler effect. If source is approaching, so the first thing you need to understand, if source is approaching observer, frequency observed will be greater than frequency of source. If source is moving away, the second point you need to understand, if source is moving away from observer means from detector, moving away from observer or moving away from detector. In that case, the frequency heard by observer means observed frequency that will be less than frequency of the source. So these are the 2 points simply you need to understand. Now from here we need to find out is the source is moving to the left or is the source is moving to the right. But if you look at the waves on the left side, these waves are very close together. So this is telling us the source is moving to the left and the source is moving away from y. So source is moving towards x. It means the frequency observed by x. It has to be greater than. So here it is approaching. If you want to write down, so the source is approaching x, that the source is moving away from y. We can also write down moving away from y. So in this case, fx has to be greater than f. But fy, frequency heard by observer at y, it has to be less than f. So this is over simple. This is how you can answer this problem. Frequency at x, it has to be greater than f. So this one is true. This is also true. Now we need to find out the frequency of y has to be less than f. So this is telling us is less than f. This is telling us greater than f. So this is not right. So the possible answer, best possible answer for this question is C, because source is approaching x. So these are the takeaways. Means what you need to understand from this question is your takeaway is this one. If the source is approaching observer, frequency observed is greater than fs. If it is moving away, observed frequency is less than frequency produced by source. But another important point is that frequency of the source fs does not change. It doesn't matter source is approaching or source is moving away, fs does not change. In next time they can ask you about this one. Frequency of the source does not change. What is changing is the apparent frequency, observed frequency. So fs does not change. Next time in paper they can ask you about fs, so be careful. So these are 3 takeaways from this question 2, and this is the third one. Source frequency does not change. For question number 25, we need to find out what is not a possible value for the wavelength of the named electromagnetic waves when it is traveling in a vacuum. And this question is simply based on range of different electromagnetic waves. We need to remember the range of all electromagnetic waves to answer this question. First of all, let's try to understand how we can remember the range of electromagnetic waves. Let me explain to you in a very simple way. We will start from radio waves, and radio waves, they have the longest wavelength. So the wavelength is greater than 1 meter. So simply I will write down here, the wavelength is greater than 1 meter. So it's greater than 1 meter, greater than 1 meter. So it can be from 1 meter to 10 to 2 meters and so on. So it is greater than 1 meter. So simply you can remember the wavelength of radio waves is greater than 1 meter. Let's move on to next wave. Next one is microwave. And the wavelength of the microwaves, it is from 1 meter to 10 to negative 3 meters. So we are using units meter. After microwave, the next wave is infrared. And the wavelength of infrared is from 10 to negative 3 to 10 to negative 6. Again, the unit is meters. Next one is visible light. For visible light, the wavelength is from 8 times 10 to negative 7 to 4 times 10 to negative 7. But most of the time, we also remember this one. It is from 400 to 800 nanometers. So it is from 400 to 800 nanometers. So this is also important if you can remember in nanometers. And next one is UV light, means this is ultraviolet light. And the wavelength of ultraviolet light is from 3 times 10 to negative 7 to 10 to negative 8. Next one is X-rays. So the unit for this one is also meters. So next one is X-rays. For X-rays, this is 10 to negative 8 to 10 to negative 12. For gamma, the last one is gamma rays or gamma radiations. The range you can simply remember, this is 10 to negative 12 to 10 to negative 16 and even smaller than that. So this is the range, and this is how you can simply remember this one. Now let's look at given wavelength. First of all, gamma rays. So it is given 10 to negative 3. So this is in this range. So this is right. And if you look at X-rays, this is 10 to negative 10. And that is in this range. So this is also right. That is possible. For infrared, it is given 10 to negative 6. So this is in this range. So this is also true. This is true. But if you look at microwave, this is given 10 to negative 5. 10 to negative 5 is in infrared range. So this is in infrared range. So this is not possible for microwave. So our answer for this one is D. So this is the answer. Welcome to A-Level and AP Physics. In today's lesson, we will discuss tricky and typical type of questions on waves from March 2021, paper 1-2. For question number 26, it is given to us there are two waves P and Q. These two waves meet at a point X and superpose. Initially, the two waves are in phase. It simply means that there is no phase difference. The resultant wave has an amplitude of 14.0 centimeters at that point. It is also given to us the phase difference between the two waves is changed so that they meet at X with a phase difference of 180 degrees. The resultant wave now has an amplitude of 4.0 centimeters at X. Question is asking us, we need to find out the amplitude of one of the waves at point X. As it is given to us, when the waves are in phase, the resultant wave has an amplitude of 14.0 centimeters. But when the phase difference between two waves is equal to 180 degrees, the resultant wave has an amplitude of 4.0 centimeters at X. First of all, let's try to write down what is given to us. In phase. So it simply means that you need to add amplitude of individual waves. So it simply means AP plus AQ. Means AP is the amplitude of wave P and AQ is the amplitude of wave q. It is given to us the resultant amplitude, means the amplitude of resultant wave is equal to 14.0 centimeters. It is also given to us when there is a phase difference of 180 degrees, or we can say when the waves are antiphase, the amplitude of resultant wave is given that is equal to 4 centimeters. So one wave has positive amplitude, one has negative, and the sum is equal to 4.0 centimeters. Or simply we can write down, it means AP minus AQ, this is equal to 4.0 centimeters. You can also say Q has higher amplitude. You can also write down AQ minus AP, so it doesn't matter. So in this case, I'm assuming that the amplitude of wave P is greater. So that's the reason I wrote AP minus AQ. So this is equal to 4.0 centimeter. Now simply we need to find out the value of AP and AQ. So AP plus AQ is equal to 14.0 centimeters. So we simply add these two together. So we can say this is equation 1. And this one we can say this is second. First of all, we need to add these two. 1 plus 2. We add 1 and 2. So we can write down AP plus AQ. This is equal to 14.0 centimeters. And AP minus AQ. This is equal to 4.0 centimeters. Now simply we need to add these two. If we add them together, we can simply cancel AQ with AQ. So we left with AP, 2AP. This is equal to 14 plus 4. It is equal to 18.0. So from here we can find out AP. This is equal to 9.0 centimeters. So this is the amplitude of wave P. Now we can find out amplitude of wave Q using equation 1 or 2. I will be using equation 1. So simply you need to plug in value of AP in 1. In equation 1, we have AP plus AQ. This is equal to 14.0 centimeters. AP we have found, this is equal to 9.0 centimeters. Now we need to find out what is amplitude of wave Q. So that will be simply equal to 5 centimeters. So AQ will be equal to 5.0 centimeters. So this is amplitude of wave Q. Question was asking us to find the amplitude of one of the wave. Now we have answer that is equal to 9.0 centimeters, and this is amplitude of AP, and we have amplitude of wave Q, AQ, that is equal to 5.0 centimeters. So our answer for this question will be B. For question number 27, it is given to us a water wave is diffracted as it passes through a gap between two barriers in a ripple tank. The wave is observed to spread out as it moves through the gap. Which two factors both affect the amount of diffraction observed? Means which two factors, both factors. Very important. It's telling you both factors. Means not one of them. If you look at first one, amplitude does not affect diffraction. Frequency of the incident wave, it is linked with the wavelength, so it does affect. So option A is not right. So both of them has to affect the amount of diffraction. B is also not answered based on the same reason, because amplitude of the wave does not affect diffraction. And the C is also based on the same reasoning, does not affect the diffraction. But wavelength, it does affect. Frequency is linked with wavelength, we can say it does affect. Size of the gap, it does affect. Now if you look at option D now, we have two factors, wavelength of the incident wave and size of the gap. So these two affect. That's the reason word is written both. So very important one. Now let me explain to you a little bit. So answer is D actually. Let me explain to you a little bit more about diffraction, because you need to take away something from this question, not just you find the answer of this one. Diffraction depends on two main factors. One factor is the wavelength of the wave, so wavelength of the incident wave. Second thing, it depends on size of the gap. It depends on size of the gap. So it depends on these two factors. If the wavelength of the incident wave is equal to the size of the gap, means about equal to size of the gap, significant diffraction takes place. Size of the gap. So this is main point. They will ask you this one in many different ways. Size of the gap. So in that case, significant diffraction takes place. So significant diffraction. This is the point what you need to take away from this question. So this is the main concept. So this is one concept and this is the other one. Means diffraction depends on, we can simply write down diffraction depends on, it depends on two factors. So diffraction depends on, it depends on lambda of the incident wave, and it depends on size of the gap. Let's try to understand this one with one simple figure. You can see, if you look at this diagram, you can see from here, wavelength, this is the wavelength, means the distance between these two wavefronts. This is smaller than the gap, means the size of the gap. So in this case, diffraction is very low. If you look at, waves are supposed to go this way straight if there is no gap, there is no barrier. Now you see they just diffract very little. So this is amount of diffraction. They spread out very little. So in this case, diffraction is very low. But if you look at the next figure, in this figure you can see the wavelength of these waves is about equal to the size of the gap. So in this case, you see waves are supposed to go this way, and means the waves spread out. So this is significant diffraction. So in this case, significant diffraction, or you can say high level of diffraction. So this is significant diffraction. Significant. So this is all what you need to understand about question 27, and these are the takeaways. One, and this is the second one, and this is third one. For question number 27, it is given to us two sources of microwaves P and Q produce coherent waves. Means the phase difference between waves is constant, or simply we can say constant phase difference. So simply we can write down coherent is telling us constant phase difference between waves. It is given to us they have a phase difference of 180 degrees. The waves have wavelength equal to lambda. At the point S, there is a minimum in the interference pattern. Minimum in the interference pattern is also telling us that the waves are in antiphase when they reach at point S. QS minus PS. QS means the distance from here to here. This is QS and this is distance PS. Is called the path difference. We need to find out which expression could represent path difference. The best way to find the path difference is simply we can draw the normal line from here. If we draw this normal line, now if you look at these two, you can see that this distance, mean distance from here to here, this distance is about equal to distance from here to here. So these two distances are equal. So the extra distance, this one is the extra distance, and this extra distance is called path difference. So we can write down extra distance. This extra distance simply we call this is path difference. And so this is path difference. We need to understand this point. It is given to us the phase difference at this point between two waves is 180 degrees. So the best way is we can redraw these waves. So this wave, let's say, is here. So when this wave started, it has a phase difference of 180 degrees. So this wave is like this. So the phase difference between these two is 180. Where you see the crest of this wave, you will see the trough of this wave. And where you see the trough of this wave, you will see the crest of this wave. When these waves, they reach at this point, again they are antiphase. So we can redraw. This is one wave, and the second wave is in antiphase with the first wave. So this can be over second wave, antiphase. Now we need to find out what is the extra distance traveled. If this is true, means the wave started from here, they're antiphase. They're here also gain antiphase. So it simply means that the path difference has to be equal to n times lambda, and n can be 0, 1, 2, 3, and so on. Now simply we can find out the path difference when n is equal to 0. So if n is equal to 0, we can simply write down when n is equal to 0. So the path difference between two waves, this will be equal to 0. And when n is equal to 1, the path difference will be equal to 1 lambda. And when n is equal to 2, the path difference will be equal to to lambda. Now we simply need to look at this one and we can find our answer. If you look at these given options A, B, C, D, and C is the best answer, because when n is equal to 1, the path difference between two waves is equal to 1 lambda. So our answer is C. For question number 29, it is given to us a beam of red light of wavelength 633 nanometers is incident on a diffraction grating with 600 lines per millimeter. The beam of red light is replaced by a beam of blue light of wavelength 445 nanometers. A replacement diffraction grating is used. Replacement diffraction grating replace simply is telling us different diffraction grating is used so that the first order maximum of the blue light appears at the same position. So it simply means that sine of theta is the same for blue and it is same for the red light. So this is same. Sine of theta is same. First order maxima. It is also telling us that n is the same for the blue light and it is also same for the red light. So n is also the same. What we need to find out? We need to find out how many lines per millimeter are there in the replacement diffraction grating. So that we are talking about diffraction grating. So simply we can start from here. D sine theta, this is equal to n times lambda. Now from here we can take sine theta on one side, and if we divide this one by n, this will be equal to lambda by d. But if you look at this side, this is constant. This is constant for blue and this is also constant for red light. So from here simply we can say lambda over d, means we can say lambda for red and this is d for red. This is equal to lambda for the blue light and d for replacement diffraction grating. So I will also use b for this one. But question is asking us, we need to find number of lines per millimeter. We understand d is equal to 1 over n. If we replace d here, we can write down this will be lambda r divided by 1 over n for the red light, means 1 over n is the number of lines. Here this is lambda for the blue light and this will be 1 over number of lines. This is 1 over number of lines for the blue. If we simplify this one, we will get lambda r times nr. This is equal to lambda b times nb. We need to find out nb. So we can rearrange this formula again. nb, this will be equal to nr lambda r divided by lambda b. nr is given. This is 600 lines per millimeter. So we can write down here. This is 600 lines per millimeter. So this is 600 per millimeter, and lambda for red light is given. So this is in nanometers. You can use nanometers here, and lambda for b is given. This is 445 nanometers. Now if you look at these units, this nanometer we can cancel with nanometer. So our answer, the final answer for this one, means the number of lines per millimeter in this case will be equal to 853 lines per millimeter, and this is what question is asking us to calculate. So our answer for this question will be D up to 2SF. So this is our final answer. For this question we need to find out which diagram best represents the field lines in the electric field produced by a combination of 1 point positive charge and 1 point negative charge. Means for 2 point charges, one is positive, one is negative. First of all, let's try to understand a few points about electric field lines. Electric field lines start or begins electric field lines. We are talking about electric field lines, so you need to be clear about this. Electric field lines begin from positive charges. Positive charges are infinity. This is one point we need to understand to answer this problem. Electric field lines end at negative charges. Electric field lines end at negative charges are infinity. And at negative charges are infinity. So these are the 2 points you need to understand. And field line, the third one, field lines are perpendicular to the surface. In electrostatic equilibrium, field lines perpendicular to the surface. So these are the 3 points we need to understand. Perpendicular to the surface. Now, based on these points, we can find the best possible option. If you look at option A, electric field lines begin from positive, but this is telling us electric field lines are they're ending at this. So this one is wrong. So this is not right. This is also wrong. So this is not possible answer. If you look at this one, again, electric field lines are coming to positive charge. So this is wrong. This part is right. If you look at this one now, this is positive charge. So electric field lines are starting from this one. So this is right. But again, they're starting from this. So that is wrong. So B is the best possible answer. You can see electric field lines start from positive charges and they end at negative charges. So this is the best answer. Welcome to A-Level and AP Physics. In today's lesson, we will discuss typical type of questions on electricity from March 2021 paper 1-2. For this question, it is given to us base of the cloud is 500 meters above the ground and this horizontal line is representing the base of the cloud. So simply we can write down here, this is base of the cloud. And this horizontal line is representing ground. So simply we can draw another horizontal line here and this is representing ground. It is also given to us the potential difference between the base of the cloud and the ground is 200 megavolts. So it simply means if we connect a voltmeter between these two, the reading on this voltmeter is 200 megavolts. So simply we can write down here. Now if you look at this setup, this is like parallel plates, capacitor. So this is like parallel plates, capacitor. So parallel plates. If plates are parallel, the field between the plates, field is uniform field, means uniform electric field. The field between these two plates is uniform. It is also given to us a raindrop with a charge of 4.0 times 10 to negative 12 coulombs is in the region between the cloud and the ground. It simply means that charge is placed somewhere here and we need to find out the force on this charge. Let's assume the force on this charge means the direction of electric force on this charge is upwards and we can say that force is Fe. And this is what we need to find out. We need to find out the magnitude of this force. Fe, simply we understand Fe is equal to EQ and E is the electric field and in uniform electric field E is equal to delta V over T, means the potential difference between 2 points divided by the distance between 2 points. In this case, the potential difference between these 2 points means between these two plates, or we can say between base and ground is given, and that is 200 megavolts. So this is 200 megavolts. So simply we can say this is 200 times 10 to 6 volts divided by the distance between these 2 points. And the distance between these 2 points is given, that is 500 meters. Now simply we need to plug in values and we can find out value of F. And so we can write down here E is equal to delta V over D and this is multiplied with Q. Delta V we have, this is 200 times 10 to 6. We need to divide by the distance between two plates, mean base and ground, and we need to multiply with the charge on the raindrop. So the charge on the raindrop is 4.0 times 10 to negative 12 coulombs in coulombs. Now if we solve this one, we will get our final answer, that will be equal to 1.6 times 10 to negative 6 newtons. So this is the magnitude of electric force on this raindrop. So that's the answer. For question number 32, equation is given to us and question is asking us what this symbol small n is representing, means what this symbol is representing. And this question is quite straightforward one. Let's try to understand first of all what is n. N simply represent number of charge carriers per unit volume. Number of charge carriers per unit volume. This represents number of charge carriers per unit volume. So simply we can write down this is what n is representing. Number of charge carriers per unit volume are simply you can say number of free electron. Number of free electrons per unit volume. So we can also write down this is number of free electrons because the charge carriers in a metal are free electrons. So we can say number of free electrons per unit volume. Number of free electrons per unit volume. We can also say this one, n is the number density of free electrons. Another way to say this one is number density of free electron. Number density of free electrons. So that's all what we need to understand to answer this question. If we look at option A, the number of charge carriers in the wire, no, this is not right. Number of charge carriers per unit volume. And n is the property of material. Property of material. So this is property of material. It depends on material. And n is different for different materials, or you can say different for different metals. The number of charge carrier per unit cross-sectional area, this is also not true. The number of charge carrier per unit length, this is also not true. The number of charge carriers per unit volume, this is true. Number of charge carriers. So our answer for this question is D, and this is the answer. For this question, it is given to us a cell of negligible internal resistance is connected to resistors R1, R2 and R3 as shown in this circuit. We need to find out which equation must be true, must be correct, must be true. If you look at option A, for this one, it is given to us the power dissipated in R1 is equal to power dissipated in R2 plus power dissipated in R3. For this one, simply we can write down, this is telling us the power dissipated in 1 is equal to power dissipated in 2 plus power dissipated in 3. For that purpose, let's assume current coming from this cell, let's say is I, and current passing through this resistor 1, let's say this is I1, and current passing through these two resistors, let's say this is I2. Now simply we can write down the equation for power dissipated in these resistors. We can also connect voltmeter. Let's say if I connect voltmeter across R1, the reading on this voltmeter will be equal to the potential difference across the terminals of this power supply, or we can say because it has no internal resistance, so this will be equal to EMF of power supply. We can say that is equal to V. We can also connect voltmeter across these two resistors. If we connect voltmeter across these two resistors like this, the reading on this voltmeter also will be equal to the EMF of power supply. Now simply we can use this one and we can find out are these two they're equal or not. So for P1 we can say this is V squared divided by R1. And for P2 plus P3, we can write down this will be equal to V squared divided by the total resistance of these two resistors. Simply we can say R2 plus R3. And this is only true if R1 is equal to R2 plus R3. Only true if this condition is met. So only true if R1 is equal to R2 plus R3. But it is not given to us they are equal. So this option is not possible. So we can simply say they may not be equal. May not be equal. So if this is the case, then option A is not true. They may not be equal. So option A is not correct. Let's go to option 2 now. If you look at option 2 means option B, power dissipated in R2 is equal to power dissipated in R3. So we can write down equation again. For this one simply we can say P2 is equal to P3, and that this is only possible if I square, we can say I square R2, this is I2. This has to be equal to I2 squared times R3. And this is only true if R2 is equal to R3. But it is not given to us they are equal. may not be equal, maybe not equal. Simply we can say maybe not equal. If they are equal, then it is true, but maybe they are not equal, so it cannot be best possible option. If we go to option C now, for option C, it is given to us the power output of cell, we can say EMF of the cell times the total current passing through the battery. This is equal to power dissipated in R1. We can say this is I1 squared times R1, and next one we can write down this is I2 squared times R2 plus I2 squared times R3. And this is always true because this is simply based on conservation of energy. Means all the electrical energy has to be converted into other forms of energy. Or simply we can say this is simply based on conservation of energy. If you look at option D, it is given to us power output of cell is equal to power dissipated in R1. And this is not correct because this is against conservation of energy. All the power output of the cell has to be equal to the power dissipated in all the resistors, mean in these three resistors. But this is telling you only in one resistor. So that's reason this is not correct option. For question number 34, it is given to us a fixed resistor and a diode are connected in series to a battery of electromotive force 6.0 volts and negligible internal resistance. It simply means battery has no internal resistance. It is also given to us current in the circuit is 40 milliamps. If you look at this circuit, we can find current in the circuit. As these two components, they are connected in series, it means current passing through this diode and resistor is the same. We need to find out what is the resistance of this fixed resistor. It is also given the IV curve for diode is given. So IV curve for diode is given. If you look at this curve, current in the diode is 40 milliamps. So simply we can draw this horizontal line. And then we can find out the potential difference across diode. So potential difference we can simply read from x-axis. Potential difference, if we read, this will be equal to about 1.24 volts. So this is the potential difference across diode, means if you connect voltmeter across this diode, reading on the voltmeter will be 1.24 volts. Now simply we need to understand EMF of the cell. This will be equal to the potential difference across fixed resistor plus the potential difference across diode. I'm using letter capital D for diode here. EMF of the cell is given. This is 6.0. VR we need to find out. And potential difference across diode is given, that is 1.24 volts. So VR from here, simply we can find out this will be 6.0 minus 1.24. If we simply solve this one, our answer will be 4.76 volts. We can simply connect voltmeter across this resistor and the reading on this voltmeter, that will be equal to 4.76 volts. And current passing through this resistor we have, and value of the current is 40 milliamps. So this is 40 milliamps. Now we need to find out resistance. So resistance, simply we can find out this will be equal to potential difference across the resistor divided by current passing through this resistor. Potential difference across this resistor is 4.76 volts and current is 40 milliamps. So 40 milliamps. Our final answer, if we solve this one, will be 120 ohms. So the answer is B for this question. So this is how you need to approach. For question number 35, it is given to us an electrical cable consists of 7 strands of copper wire, each of diameter 0.30 mm, and they are connected in parallel. Resistivity of copper is given, current in the cable is given. We need to find out what is the potential difference between 2 points on the cable, a distance of 1.0 meter apart. If you look at this sketch, I have already drawn this one, and this gives you very clear picture of this question. And in this sketch, you can see this is the outer side of the cable. So I have sketched this one. This is outer side of the cable. And inside this cable, there are 7 strands. As you can see here, these are the 7 strands are 7 copper wires inside this cable, and these strands, they are connected in parallel. So we can find out current passing through each strand, means passing through one strand. Simply we can write down here, and that current will be equal to 13/7 because they are connected in parallel, so current will be equally divided. Now we need to find the potential difference between 2 points at a distance of 1 meter. We can take these 2 points on any one strand because they are connected in parallel, so the potential difference across them is the same. Now simply we need to use V is equal to IR. In this case, I is given, that is 13/7. So again, let me write on I. R we need to find out. R will be equal to rho L by A. Rho L by A. Now we can plug in values. Current is 13/7. Rho is given, that is 1.72 times 10 to negative 8, and L is given, that is 1 meter. So L is 1 meter, mean the distance between these 2 points, and we need to divide by the cross-sectional area, but diameter is given. We can say this is pi by 4 d squared. So d in this case is given, that is 0.30 millimeters, and the power of d is 2. Now simply we need to solve this one. If we solve this, our final answer will be 0.451 volts. So the answer for this question is C. This is how you can answer this problem. Welcome to A-Level and AP Physics. In today's lesson, we will discuss some important past paper questions on electricity and radioactivity from March 2021, paper 1-2. For question number 36, it is given to us a cell that has internal resistance is connected to a switch S and a variable resistor. A voltmeter is connected between the terminals of the cell as shown in this figure. Means voltmeter is connected across terminals of the battery, and this is voltmeter. It is given to us when switch is open, voltmeter reads 1.50 volt. The switch is then closed and variable resistor is adjusted to have a resistance of 4 ohms. The voltmeter now reads 0.75 volts. Question is asking us to calculate what is the internal resistance of the cell. For this question, it is given to us when the switch is open, voltmeter reading is equal to 1.5 volts. It simply means that there is no current in the circuit. As there is no current in the circuit, the voltmeter reading will be equal to EMF of power supply because there will be no energy loss in the power supply. So simply we can say EMF is equal to 1.5 volts. It is also given to us when the switch is closed, mean when we close the switch, resistance of this resistor is equal to 4.0 ohms. It is also given to us the voltmeter reading now is equal to 0.75 volts. Simply we can connect another voltmeter here. Let's say we connect another voltmeter across this variable resistor. Reading on this voltmeter also will be equal to 0.75 volts. Now we have EMF of power supply. We can write down EMF will be equal to VT, means the terminal potential difference plus the V lost in the battery. So this is V lost. EMF is equal to 1.5 volts and terminal potential difference is equal to 0.75 volts. Now from here we can find out value of V lost. V lost from here will be equal to 0.75 volts as well. Now if you look at the value of terminal potential difference, means the potential difference across this resistor or across the terminals of power supply, that is also equal to 0.75 volts. As these two potential difference, they are the same, and current passing through the internal resistance, means internal resistance is here and this is our external resistor. As current passing through each of them is the same, so we can simply write down IR. This will be equal to I times capital R. As current is the same, so it simply means that small r this is equal to capital R, because V lost, this is equal to Vt, means the terminal potential difference. So from here simply we can find out internal resistance, this will be equal to 4 ohms, because capital R is equal to 4 ohms. So this is one way we can calculate internal resistance. But another way to calculate internal resistance is, first of all, we can calculate value of I. If you look at this external resistor, we have potential difference across this external resistor. Simply we need to divide by its resistance, and the resistance of external resistor is 4. So simply we divide 0.75 by 4, and value of current will be 0.187 amps. So this is current in the circuit when the switch is closed. So simply we can write down this is value of I. Now we need to find out internal resistance. Internal resistance V lost is equal to I times small r. We need to find out internal resistance. So V lost is equal to 0.75. We need to divide by I, that is 0.187. So our answer will be 4 ohm. This is another way you can find internal resistance. So answer for this question is C. For question number 37, it is given to us a cell of electromotive force capital E and negligible internal resistance is connected into a circuit as shown in this figure. The voltmeter has very high resistance and reads a potential difference V out. Voltmeter has very high resistance. It simply means that this is an ideal voltmeter and no current will pass through this voltmeter. Negligible, simply we can ignore that. We need to find out the ratio between V out and E. We can answer this question using different methods. Let me explain to you using the simplest method to answer this problem. For that purpose, we need to redraw this circuit so you can see the clear picture of this circuit. So as you can see, the cell is given and there is one resistor that is connected across this cell. So this is that resistor, and EMF of the cell is given is capital E. Resistance of this resistor is given, that is 12 ohms. Next we have two resistors, and these two resistors, they are connected in series. So this is one resistor and another resistor that is connected in series. So simply we can redraw circuit like this. So simply we can connect voltmeter here. This is connected across 4 ohm resistor, and the reading on this one is V out. This resistor has resistance of 2 ohms and this is resistor of 4 ohm. Now simply we need to find out the ratio between V out and E. In order to find the ratio between V out and E, we can simply connect another voltmeter across these 2 points. Across these two points is the same. If I connect across these 2 points another voltmeter, let's say this is an other voltmeter, the reading on this voltmeter will be equal to EMF, because this point is connected with positive terminal and this one is connected with negative. So the reading on this one will be capital E. So this is capital E. From here we can say that the ratio between E over total resistance in this branch, that is 2 plus 4, has to be equal to the V out, means the reading on this voltmeter divided by this resistance by 4. Now we need to find out V out. Simply we can write down V out by E. This will be equal to 4 divided by 2 plus 4. Now if we simplify, our answer will be 2 by 3. So that's the answer. So the answer for this question is 2 by 3, and this is the answer. So this is the simplest way you can find out. Question number 38 is a typical type of question on potentiometer. For this question, it is given to us a battery is connected to a potentiometer. The potentiometer consists of a uniform resistance wire and a sliding contact P. This is uniform resistance wire. It is connected between Q and R, and P is sliding contact. We need to find out which graph shows the variation with distance d of the potential difference V, means the reading on this voltmeter. First of all, let's try to find the potential difference between point P and point Q. So we can simply write down VPQ, and VPQ will be equal to current passing through this wire times the resistance between point P and Q. So we can say RPQ. We also need to understand, as this voltmeter is ideal voltmeter, it simply means that its resistance is infinite. If the resistance of this voltmeter is infinite, it means there will be no current passing through this rod. So this is a very important point. We need to be very clear. It also means that if current I is coming from this power supply, current I will also pass through this wire, but no current will pass through this voltmeter. Now, if you have this understanding, now simply we can write down I times the resistance. Resistance of the wire, we can say, is the resistivity of the wire times, we can say, the length of the wire. So we can say rho times LPQ divided by cross-sectional area of the wire. Now in this case, I is the same, so current passing through QP and current passing through PR is the same. So we can take I out. And wire is the same wire, because this is the same wire between point Q and P and also between point P and R. So rho is also constant, because the same wire, it is made of the same material. It means resistivity is the same. Wire is the same, so it means cross-sectional area is also the same. Now simply we left with L, in this case LPQ. So this is LPQ, this is equal to D. So we can also write down here. So we can replace LPQ with D. So this is D. Now if these quantities, they are constant, we can simply say that VPQ will be proportional to D. We can also say that VPQ means we can write down VPQ is equal to some constant times D. And constant in this case, I is constant, E is constant, means the rho is constant, and cross-sectional area of the wire is also constant. So these quantities are constant. Now from here we can simply sketch a graph between two quantities, and these two quantities, they are directly proportional. If two quantities are directly proportional, the graph has to pass through origin and it has to be a straight line. So this is simply telling us y is directly proportional to x. So the answer for this question is A, because V is proportional to D. So the best answer is A for this question. For question number 39, it is given to us an unstable nuclide X decays by emitting an alpha particle. Which nuclide is formed by the decay of nuclide X? For this question, it is given to us an unstable nuclide X decays by emitting an alpha particle. First of all, let's try to understand what is alpha decay. If we have better understanding of alpha decay, we can answer this question very easily. Alpha decay is simply, let's say we have nucleus X and the atomic number of this nucleus is Z and the mass number is A. This decays to another nucleus Y by emitting alpha particle, or by alpha decay. Alpha particle has atomic number 2 and the mass number 4, means it has 2 protons and 2 neutrons. So the atomic number of this new nucleus will be Z minus 2, means the proton number will decrease by 2. Atomic number is equal to proton number, and the mass number of this one will decrease by 4. Or we can simply say that in alpha decay, proton number decreases by 2. So we can write down proton number decreases by 2. You can say minus 2. And a neutron number also decreases by 2. So we can write down neutron number also decreases by 2. So we can write down negative 2. Now simply we need to look at this nucleus X. Its proton number decreases by 2. So it has proton number 94. Now it becomes 92. So simply we can draw this line here. So proton number decreases by 2. And neutron number also decreases by 2. So if we go down, this is telling us neutron number decreases. And this decreases by 2. So this is our new nucleus. This is new nucleus. So the answer is B for this question. For question number 40, we need to find out which nucleus contains equal numbers of up and down quarks, means up and down quarks. We can look at each nucleus and then we can find out which nucleus has the same number of up quark and same number of down quark. I will simply go to helium first of all. If you look at helium, it has atomic number 2 and the mass number is 4. This is telling us it has 2 protons. So simply we can write down it has 2 protons. Atomic number is 2 and atomic number is the same as proton number. And its mass number is 4 and the mass number is equal to number of protons plus number of neutrons. So the neutron, we can say the number of neutrons in helium nucleus, they are equal to 2 as well. Next thing we need to understand, proton, this consists of 2 up quark and it consists of 1 down quark, but we have 2 protons, so we need to multiply by 2. Neutron consists of 1 up quark and 2 down quark, and there are 2 neutrons in the nucleus, so we need to multiply with 2. From here we can write down the number of up quark, 2 times 2, so we have 4 up quarks in 2 protons and we have 2 down quarks, so we have 2 down quark here. Now if you look at neutron, neutron has 1 up quark and if we multiply with 2, so it has 2 up quark, and it has 2 down quark and we multiply with 2, so it has 4 down quark. Now if we look at the number of up and down quarks, so these here we have number of up quarks, so the number of up quarks we have total 6, and if we look at number of down quarks, we also have 6. So helium nucleus has the same number of protons and same number of neutrons, also the same number of up quarks and same number of down quarks. So the answer is B, but you can check remaining nuclei by yourself one by one. You will see that up quark will not be equal to down quark, means the number of up quarks will not be equal to number of down quarks. For the remaining nuclei, they will not be equal. So only in this case, helium nucleus had the same number of protons, same number of neutrons, and also same number of up quarks and same number of down quarks.